Hi, this is Dhruv Leela and this is my submission for the CML102 Assignment 2. In this assignment, we were given three single crystal XRD datasets, and using those datasets, we had to solve for the different crystal structures using the OLX2 software. Then we had to make a crystal packing diagram using Vestra for each crystal structure we had, and also obtain the powder XRD patterns. So yeah, the way OLX, so basically the data which was given to us for each crystal had two files, the INS and the HKL file, which had the intensity values for different HKL planes and the information regarding lattice cell parameters, space group, and so on. So basically, when we fed that data to OLX2, OLX2 software, it basically gave us the plausible, basically gave us peaks, electron density peaks, where the atoms could possibly lie, and using those peaks we can assign, and we can assign each atom to a peak and obtain a possible molecular structure, and then place those molecular structure in the crystal, which using appropriately using the space group and the lattice cell parameters which are given, and we can obtain the crystal structure then, and then obtain the powder XRD pattern. So the first data set which was given to us was hydrochlorothiazide, which has a benzene ring and a 6-member heterocyclic ring attached to the benzene, and also sulfonamide and chlorine group attached to the benzene ring. So when we open the dataset in OLX2 software, we can clearly see a hexagon being formed by 6 of the peaks, and this gives a very good indication that this is indeed a benzene ring, position of the benzene ring. So we can assign carbon atoms to each of these peaks, and and right next to benzene ring we can again see a 6-member non-planar ring, which gives an indication that this is also the position of the heterocyclic ring we have, and so we can assign carbon atoms to these peaks and obtain a 6-membered ring which is non-planar. Now this atom, it was initially assigned chlorine by the software, but it should actually be sulfur, because since this atom is a bit out of place, this indicates that this position is the atom in this position is sp3 hybridized, so it must have a tetragonal geometry, and the 4 groups must be attached in tetragonal fashion. So, and from the structure which is given to us, it is clear that atom is indeed sulfur. Now sulfur and chlorine have very similar atomic scattering factors, since their atomic numbers are very similar. So this could be the reason why the program maybe got confused between sulfur and chlorine. So if we attach sulfur here and attach 2 oxygen atoms to it as shown, now we know that this and this should also be nitrogen atoms, so we can put nitrogen atoms here. As we can see, the blue atoms are nitrogen atoms. Now we can put chlorine here and the sulfur atom here, because we know from the structure that the atom opposite to sulfur here is chlorine, and here we have sulfur, so we can put the atoms, assign the atoms appropriately. Here also the program got confused between sulfur and chlorine, but we know from the structure that this should be chlorine and this should be sulfur. Now we also had to attach 2 oxygen atoms and an NH2 to sulfur. Now the way I did it was, we had 3 peaks near the sulfur atom, and so I assigned oxygen to all of them, and basically one of the bond length I was getting was longer than the other 2, and obviously the bond length of the sulfur nitrogen is obviously smaller than the bond length of is larger than the bond length of sulfur oxygen double bond. So this gave me a pretty good indication that the bond which was unusually longer was the sulfur nitrogen bond. So I assigned oxygen nitrogen like that. So this gave us the tentative structure of the compound, and when we computed the R value, we got 7.13%. So which is a decent value. To like refine it further, what I did was I assigned hydrogen atoms. So this structure doesn't have hydrogen atoms, but in reality, obviously, hydrogen atoms are present in the structure. So the program does that for you. So I assigned hydrogen atoms, and yeah, another thing I did was instead of modeling every atom as a point, single point or a small sphere, we can like represent it as in the form of ellipsoids. This is because the atoms are not fixed on one position in a molecule, in a crystal, and they thermally vibrate, and so it is better to model atoms as ellipsoids. So that's why I assigned represent every atom as ellipsoid. So we can do that from this off. So we can do that using the button which is given here in the software. So when we do that, we get the final R value as 3.75, which is like very good. And as discussed in class, we any R value lower than 5% is very good. So and we got 3.75. So we can say that the structure we obtained is like very close to the reality. Now we make the CIF file and open it on Investa, and we obtain the following crystal packing diagrams. So crystal structures. So as we can see, the benzene rings here, the sulfonamide group, and the heterocyclic ring here, and so on. So chlorine here, and yeah. So this gave us the structure, and it is in the report. And since we pretty much assigned every atom a fixed position, we can like very easily obtain the powder XRD pattern using the software. So by one click. So when we do that, this is the XRD pattern we get. So yeah, so that was dataset 1. Dataset 2, which was given to us, was ribosol plus malonic acid. So ribosol has a 6-membered benzene ring again, and a 5-membered heterocyclic ring attached to the benzene ring, and an OCF3 group. And malonic acid is basically 3 carbons and like 2 carboxylic acid groups attached to it. So again, when we open the dataset in OLX2 software, like we could again see a 6-membered ring here, which indicates the position of benzene ring. And yeah, so when we do that, again we see a sulfur atom attached to the benzene ring by default. And as we can see from the structure, no other atom has an atomic number close to sulfur. So we can be confident that this atom is indeed sulfur, and since there is only one sulfur in the whole structure, we can be confident that this is also indicates the position of the 5-membered ring. So since we have sulfur here, we can like complete the ring and like assign carbon here and nitrogen here. Like we can be sure like the sulfur here is this is the sulfur. So we form the 5-membered ring, attach nitrogen here and here to obtain this structure. Now as you can see, this atom here is like sp3 hybridized, it is like sp3 hybridized. So this indicates that this atom is carbon, and it is attached 3 fluorine atoms and an oxygen atom, like as given in the structure. So when we do that, we get the final structure of the ribosol. And I'm sorry. So now the remaining atoms here, like they clearly form the structure of the malonic acid. Like we had 3 carbons and like 2 oxygen atoms attached to the 2 terminal carbon atoms. So this indicates the structure, the malonic acid, the plot we obtained. So now, so this is the structure we get, and like when we refine the structure, we get an R value of 9.32. Now we optimize the structure by adding hydrogen atoms. So we add hydrogen atoms, and yeah, so after adding hydrogen atoms, we get an R value of 7.33. And then again, when we model the atoms as ellipsoids, we finally get the R value of 3.89, which is again below the R, which is below 5%. So again, it is like it should be fairly accurate and like pretty close to reality. So again, we obtained the crystal packing diagram using the Vesta software. Created a CIF file using the OLX2 software and opening it in Vesta, and yeah, so we obtained the crystal structure. So these are some photos of the crystal structure which we obtained, and yeah, again we can obtain the powder XRD pattern from with a single click, and yeah, this is what we get. The data set 3 was ribosol plus orthophosphoric acid. So again, when we opened the data set, we obtained a 6-membered ring here, which indicates the position of benzene ring, and using the very same procedure as we did in data set 2, we can obtain the structure of ribosol. Now again, we have an atom here and 4 atoms in the tetragonal position. Basically, it indicates that this atom here is sp3 hybridized and we have 4 atoms around it. So this also indicates that we have maybe a phosphorus atom here and 4 oxygen atoms. So we can assign phosphorus and the atoms around it oxygen atoms, peaks around it oxygen atoms. So this is what we get. And when we refine the structure, we get an R value of 10.22. Now when we add hydrogen atoms to the structure, this is the R value reduces to 9.64, and yeah, as we can see, one of the hydrogen atoms missing from the phosphoric acid, which makes it orthophosphoric acid salt. Now again, when we model the atoms in ellipsoid, we get the final R value as 3.31, which is again fairly accurate. And yeah, we can obtain now form the CIF files, open it in Vesta, and get this crystal structure, as we can see. And again, from the single click, we obtain the powder XRD pattern. So yeah, this was it, and yeah, this was the assignment of the CML102 from my side.